Good morning, everyone. Thanks, Jonathan and Gillian. My name's Craig Purnell from Universal Robots, and I'm going to give you all an introduction to what cobots are and talk about how you can implement cobots through our 3IP method. So I'll start off discussing what Universal Robots are, what a cobot is, 3IP, then some customer case study stories and videos, and then onto the UR Plus ecosystem. So Universal Robots, we're a Danish company and we're based in the town of Odense. The town's famous for just two reasons. It's the birthplace of Hans Christian Andersen, and it's a robotics hub. Over 150 robot companies based there. So you've got ourselves based there. You've also got On Robot, who make the grippers, talking later, who are also based there, and Mir Industrial Robotics, who are talking later again. So for such a small place, so many robot companies, it really makes it the European center for robots. And we make collaborative robots or cobots, and we've got 60,000 of them sold worldwide and 6% of the market share. So we're the biggest company doing collaborative robots. And part of the reason for that is in 2008, we made the first commercially ready collaborative robot. And it was about 2015 when we got big investment in the kind of legislation changed. And that's when they really started becoming a really big part of industrial manufacturing. So as Jonathan talked about before, there's a big difference from industrial robots and collaborative robots. Industrial robots have been around for a very long time and they're very good at what they do, but there is some limitations. And a collaborative robot, kind of newer concept, is meant to work next to people without any kind of safety fencing or guarding. And so it allows these kind of robots to both do different tasks. You know, industrial robots, as Jonathan says, can move faster and lift heavier weights. So they're the only robots available to move cars around, whereas collaborative robots can work integrately and can share tasks with a person. So again, opens up new avenues for those kind of robots. So another thing that we like to state is 5 kind of key points from us, which is the easy programming, the fast setup, the flexible deployment, the collaborative and safe, and they've got a very fast payback. So in terms of easy programming, it's a user-friendly 3D interface. It's not some kind of C++ programming you've got to do with it. It's all laid out so that anyone could kind of pick it up and learn it. It's got a free drive button, allowing you to press this button and move the robot to where you want with your arm. So that's a lot faster in setting up than traditional up, down, left, right keys, all that kind of stuff. So a lot faster in that regard. And when you're setting a program up, it's all just drag and drop. So you'll just drag from the left-hand side, the move command, tell it to go to this position, then drag across, gripper close, drag across, wait for this signal. Very simple laid out. Another thing about collaborative robots is because they're inherently safe, if you were to make a mistake during the programming, it's not too much of an issue. If it was to bump into the wall or a person, it's just going to stop safely. Whereas you can't afford to make these mistakes with an industrial robot. They can tend to potentially break the robot or seriously hurt someone. So that's the kind of advantage of collaborative. You can kind of just fumble your way through programming to set up yourself. It's fast to set up as well. So there's no complicated flooring or reinforcement you've got to do or special three-phase power supply. It's just 1 hour to unpack it from just the 2 boxes it comes in, the control and the arm, and it's a regular plug socket. So you can get it delivered to your factory from a regular courier and it's feasible you guys could install it yourselves. They're very flexible and adaptable. So all you got to do is upload a new program, change a gripper, and you've got a brand new robot. So compared to an industrial robot where you might buy it in to do a specific job, a collaborative robot is much more flexible in terms of being able to do several jobs, which gives you a lot more flexibility if production wants to change in the future. If you installed an industrial robot on line 1 and then you suddenly had less volume of that product coming through, you're kind of stuck with the robot just gathering dust. With a collaborative robot, you can just move it somewhere else in the factory and have it do something else. And it's safe as well. So we've got 17 safety functions which are category 3 certified, which is the same level of safety as an e-stop button. So it's never going to be able to override this inherent safety in it. And if it has a collision, it's constantly monitoring the force and it sees it's bumped into something and just puts it into a safe car stop. We've got 4 robots in range. The smallest being the 3E, which lifts 3 kilograms, with 500mm working radius. That's very good for short range applications like tabletops. And the other end of the spectrum, we've got the 10E, which lifts 12.5 kilograms with 1300mm working radius. And that's very good for long reach applications, such as palletizing or loading parts in and out of a CNC machine. And in terms of applications, absolutely varied. Any kind of industry, any kind of applications, a cobot could potentially do it. As long as it's a repetitive task, it's suitable for a cobot. But one thing all the applications a cobot has in common is it always replaces one of the 3D tasks. These are the dirty tasks, the dangerous tasks, and the dull tasks. The kind of tasks that employees don't want to be doing or shouldn't be doing anyway. And you're always going to get a benefit from putting a cobot into these tasks as well, potentially quality, productivity, or safety. For example, with quality, if you're a task which required a very steady hand, an employee is very good at that, but only for a short period of time. Towards the end of the day, they might get tired and the quality slips down. You obviously don't get that with a robot. Productivity as well. Employees tend to slow down towards the end of the day. They take breaks, they chat, all that kind of stuff. Cobots, constant pace all the time. And safety as well. If you've got a task which is, say, screwdriving, you could potentially get repetitive strain in your wrist after doing that for a long time, whereas obviously you're eliminating that risk by using a cobot or robot instead. And so this is talking about our method to implementing cobots into your factory, the 3IP method. It's basically looking to identify where you can use cobots, implementing those cobots as easily as possible, improving where the cobots are installed, and measuring your profitability. So when it comes to identify, we're always saying you want to identify simple applications first. Something that's a low impact installation, which doesn't require a lot of extra equipment. Something such as palletizing. With palletizing, you might just need a cobot and a photocell to say that the box is in position. And so it's something really simple to retrofit into a line. Or something like screwdriving as well. Again, it's very simple just to replace a screwdriver and a cobot and you've got a working solution from there. Or a task where you can get extra hours of productivity. If there's a machine you could run through the night with the cobot, that's a fantastic place to put in, getting you more hours of productivity. Or where you can redeploy the most staff elsewhere to where they can actually add value. And you want to encourage your employees to help. So this is probably one of the most important things when you're looking to install cobots in factories. Cobots aren't here to replace jobs. In the name itself is collaborative robots. It's here to work with employees. We always say they're looking to replace tasks rather than jobs. If you've got a cobot doing the palletizing, it's not safe for an employee doing that long term. So a cobot doing that task of palletizing is better for the workforce. But there is jobs that cobots can't do and robots can't do. They can't do everything in factories. So there's definitely a need for people and robots and automation to work together. And by having employees encouraged to help what kind of jobs they like doing the least and what's most annoying, etc., helps get buy-in and helps everyone more happy with the installation of cobots. And then when it comes to implementing the cobot, we've got a lot of resources available for free. You can get free academy training, which I'll touch upon in the end. You've got industry-specific webinars you can watch to see similar case studies to yourselves, or ebooks on your industry. You can get a free line walk from Universal Robots rep like myself. And we've got an online free application builder, so you can see how the cobot can be used in common applications, understand how the software works, and download that template to install on your current cobot installation. And we've got very flexible software. As I mentioned before, it can be adapted to change for different programs. You've got all kind of interfacing inbuilt, 16 digital inputs and outputs and Ethernet capability, so it can interact seamlessly with your current equipment. It's got powerful safety inbuilt, as well as able to interact with other safety devices on your factory. And it's got use of the user UR plus ecosystem, which I'll touch upon again at the end. And once you've got them implemented, it's about improving the work cell. You want to be measuring your increase in your output, you're increasing your quality, the reduction in cost you're getting, and you want to be constantly refining the process because flexibility is key with the cobot. If you want to have the cobot is running, the cobot's earning you money. And so on to profitability. So this is a real world example from Parker Hannifin in Yorkshire. They were under a lot of pressure from management to cut costs, and they were potentially looking at moving production to Eastern Europe, where labour was a lot cheaper. So they had to look at ways of saving money around the factory. And they had one task, which was a full-time task of one operator over 3 shifts, and essentially just picking up one component from a machine and placing it in another machine. So a very simple task. So if they thought of labour as an ingredient, they'd done a kind of cost saving or cost analysis to see what the kind of benefits be of using a cobot instead. So for the employees working 8 hours a shift, 3 shifts a day, it's about £30,000 per person a year, plus £10,000 downtime, £10,000 scrap parts, £10,000 jig and process enhancement costs. So it's about £120,000 a year to run that cell with people. So looking at a cobot instead, using our UR10E was about £31,000. The gripper was about 3.5, and about 1.5 for the fixturing, £2,000 for the table, and about £4,000 for interfacing costs. So the total cobot investment was £42,000. So you can see after 1 year, there's obviously a cost saving, but you're not having to buy a cobot every year. So your kind of cost saving is accumulative. At the end of the 5-year period, looking at total cost savings like £446,000, which is obviously absolutely massive. And the fact this company was trying to save money was a fantastic way for them to cut some costs. And if you're thinking £42,000 is a lot of money, we also do leasing options, so you can pay for your robot over a course of years, similar to how you would with a company vehicle. So on to some customer story videos. So this is Dynamic Group in the USA. They got an increase in orders, which mean they had to employ more staff, but they're really struggling to get staff in the area because they were in quite a rural part of USA. So what they did instead was they split the current number of staff over 3 shifts and had operators working with cobots on those shifts to help with the increase in orders. So the cobot's doing several things. You can see here it's picking up a couple of sachets and a bottle, and it's going to place them in a box. And the operator's working there just to make sure it's refilling the boxes and sachets and that, so the cobot can work constantly. So by having the people and the cobots work together, they're getting more out of their existing staff. This is E&O Laboratories in Stirling. They had a massive increase in COVID for production. They do some kind of petri dish product. And what they found was if they had the cobot doing the simple task of just pushing the petri dish together and then packing them in a box, the operator can be doing other things and just collecting the box at the end once it's completely packed. So by having the cobot do that monotonous, repetitive task of just packing things in the boxes, they're getting more from the current staff. This is Benham Engineering. This is a precision engineering company on the south coast of England. And they had a wide range of products they're making, some which were very intricate, ones and twos. And for that, they need a lot of operator input. So they do that during the day. But they also had some long running, really easy, repetitive stuff. And so for that, they had a cobot installed and just doing that production run through the night. So they load the tray of parts up, turn the robot on just before they leave. In the morning, they've got a complete set of work already done. So by having the cobot, they're getting more of the machines, being able to use that through the night. And finally, this is ASD Lighting. They make street lights. And what they were finding was that operators would eventually get repetitive strain by doing constantly screw driving on the lights all day long. So by using cobots instead, they reduced that repetitive strain, but they also noticed a quality increase because the cobots weren't missing screws or doing them to the wrong torque. They got better quality product. So increase in health and safety employees and better quality from using cobots. And so I'll just touch upon the UR Plus ecosystem. This is essentially like Universal Robots' version of the App Store. You can buy a gripper system, which is UR Plus certified, a vision system, some kind of pallet building software, and some range extenders. And you know it's all going to work seamlessly with the cobot. It's off the peg, plug and play ready. So it's possible you guys can get a solution yourselves by just buying these components and sticking it together. You're not needing some kind of PLC or something more complicated to control the system. You can do it all from the robot itself. And we also do a range of like off the peg kind of structures as such. So you've got like wheel tables or welding tables or a pallet building already there. So you can go just buy a welding table, for example, with a cobot, and you know you've got a working welder already ready available for you. And finally, we do a big range of academy training. So I mentioned earlier, our kind of robots are much easier to use than kind of industrial robots. We basically do a 2-hour online e-learning course where you learn the basics of how to program a robot. And then after that, you can do a 2-day in-person training on that. And that's all I've done, 2 hours online, 2 days in person. I'm pretty good at doing a cobot. But the most you can ever do with a universal robot is like about 5 days in total. So it's really not a lot of training to get yourselves up to speed with it. And we just recommend kind of trial and error with learning how to use a universal robot. And if you want to learn how to use the cobots, there's a training center in Dublin is your closest one with Reliance Automation. So they've got this already set up with the cobots for you guys to play with. Cool. Hope that was interesting, guys. And have you got any questions?
Craig, it's Gillian. I have one. So, well, a couple. So, I suppose as well, you were saying about people struggling maybe to get staff, if they're in a rural area. But I suppose if you're using cobots and technologies like that in your factory, it does make you a more attractive place for maybe younger people to come and work. They see it as,
Yeah,
it's
absolutely.
a bit more exciting and that it can build up their skills as well. So, as well as taking away, they're not going to be doing dull, dangerous, or dirty work. They're also going to be working with new technologies. Do you find that with some of the customers you're working with?
Yeah, absolutely. I think that's part of what we're trying to do as well, is just educating young people about that manufacturing isn't, you know, like the coal end, the hot end of factories all the time. That's what people always think of is kind of exciting technology. So I think Reliance doing a good job of that, going around kind of educating the younger generation of like the kind of exciting stuff you can do in manufacturing. With these kind of cobots, it's a basic level of programming, but there's obviously PLCs and industrial robots which are a bit higher level programming. So those kind of skill sets of programming I do think is quite exciting to kids these days.
Very good. Yes, no, I think I saw Reliance were doing some work with schools the other day. No, brilliant. Thank you.
Yeah,
Um, has anyone
cool.
any other questions for Craig? You can put them in the chat or unmute yourself. I guess I have another one. You were saying as well about it allows people, if you get a big order, you can suddenly, it's much easier to scale. But I suppose as well, some companies need to scale and they're like, we can't afford to build a bigger factory. But what you can do with a cobot then is you can make what space you have more efficient. So it's maybe not just as well trying to get more staff in and ramp up production, but it means you don't have to go out necessarily and expand your
Yeah,
physical presence.
that's it. Yeah, and I didn't kind of show any examples of that today, but you can have cobots mounted any orientation. So you can have it like traditionally mounted up the way, but you can also mount it from the side or mount it from the roof. So a cobot can be basically sharing a desk with a person, and the cobot's on the roof, the person's sitting down. So it's a lot more efficient in that way.
Optimizing the space. Great, thank you.
Mm.
Um, and are you over in Belfast for the event on the 8th, or is Universal Robots?
I don't think I'm going to be here now.
Right, okay. But I will share. And Craig, can I share your
Yeah,
presentation?
that's
If
absolutely
you want
fine. Yeah, no
to
problem.
guys,
Yeah.
and I'll share your details at the end as well. Um, super. Has anyone any more questions for Craig? No. Okay. So Craig,
Gillian.
thank
Thanks,
you very
guys.
much for that. Oh, Gary, yeah.
Yeah, it's just Craig, just a quick, it's not a question, it's more of a comment. Um, if you've ever worked in a production line, you know that when you develop a new product, you rely on feedback from your operatives to suggest better ways to put it together, improvements. Do you think that we're going to lose that with cobots, where this loop, this feedback into the product's design gets lost?
I mean, I guess in some ways, yeah. I mean, the cobot's not going to tell you anything, anything interesting, is it? So I guess that is something to bear in mind. I think that I was recently looking at a project at this food place, and they had an idea for cobots, but the line was just so new that they were planning on running it with operators for the first 6 months before they looked at cobots, because as you say, they just
Okay.
wanted to, they didn't know what you could expect, but yeah, you do miss that feedback look a little bit, yeah.
Okay.
Is that maybe I am don't even pretend to be a technical expert, but is that maybe where that sort of AI and big data an IoT sort of aspect comes in as well? Can that start collecting information on actual what's going on, and give you more management information to make decisions like that? I know it's not obviously a person in that sort of real life experience, but there's maybe
Yeah,
other information that can be collected to feed back too.
I think so. Yeah, and I think sometimes as well, like if you had an operator, sometimes they're checking for quality as well, or meant to be checking for quality. So if there's any kind of obvious defects that picked up, a cobot or a robot without any kind of additional equipment isn't going to know that. It's just going to pick up and say it's got something it shouldn't have in it. It's just going to pack it anyway. So that's why it's handy to have like cameras or any kind of other inspection system, which is again GAN the data and able to feed back into that loop, as you say, with like how many good runs you're having, how many bad runs, and work out why you think you're getting more defects that day, from a camera perspective rather than just an operator writing it down.